Hey guys, welcome to my channel. This is my first video, and as you can see, I have tried to make the process of implantation, embryo formation and placenta formation a bit easier for you. Yes, so without wasting any more time, let's begin. And also throughout this video, which is going to be for say 20 to 25 minutes, I want your complete attention on this video because every word that I say is very high yielding. So yes, let's get started. Now, what I am drawing right now is the fallopian tube with the uterus. Say this is the uterus, this is the fallopian tube. Now, as we all know that the fallopian tube will take up the egg which is released from the ovary. This process of release of the egg from the ovary is known as ovulation, right? So yes, this egg will be taken up by the fallopian tube, and at the ampulla of the fallopian tube, it will be meeting the sperm, right, which has traveled all the way up from the vagina and the cervix into the uterus, and this comes into the fallopian tube. Where are they meeting? They are meeting at the ampulla of the fallopian tube. Okay, so this is the site of fertilization ideally. Okay, so yes, this is where the sperm will fertilize this egg. Now, another point that I want you to remember is that this egg is a secondary oocyte. Okay, and the sperm which is fertilizing this egg is a mature sperm. So, the egg isn't matured. It will be matured after getting fertilized. So, this is a point which you can remember. The male gamete is mature when it is fertilizing, whereas the female gamete is still in the secondary oocyte form. Now, after fertilization, this is now known as the zygote, right? This zygote has to come into the uterus because it has to get implanted into the uterus. So, suppose I say that you ovulated on the day 14th of your cycle. Now, this zygote will take 3 more days to travel this portion from the ampulla into the uterus. And why it is traveling, it is already converted. When it reaches the uterus, it is already converted into the 16 cell stage. So yes, when it reaches the uterus, it is in the 16 cell stage. What do I mean by a 16 cell stage is you need to understand that after the formation of the zygote, my zygote will keep on dividing from 2 to 4 to 8 to 16 to 32 and so on. What are these? These are rapid mitotic divisions which are taking place in the zygote. So yes, now I have formed a 16 cell stage. This 16 cell stage will not get implanted. This is something to remember. This will not get implanted. What will get implanted is the 32 cell stage, right? The 32 cell stage, which is also known as blastocyst, this will get implanted. So before starting the process of implantation, let us see what actually a blastocyst is. So I am right now in my 32 cell stage, which is a blastocyst. So yes, now remember that this blastocyst has got 2 layers, right? One is the outer layer and one is the inner layer. The outer layer, as most of you might be knowing already, is the trophoblast, and the inner layer is the inner cell mass. This outer trophoblast will further divide into 2 more layers. Again, an outer and an inner layer. So this outer one is known as the syncytiotrophoblast and the inner one is known as the cytotrophoblast. Okay. Now a little detail about these 2 layers. Syncytium means fusion. Okay. So basically this layer has got these cells which are fused together. Their nuclei are fused together. right? You can see that there are no partitions in between the cells. Whereas cytotrophoblast consists of single cells with their own nuclei. Okay, so yes, this is a very minute detail. Now let us move on. Okay, so now a piece of information that I would tell you now is that inner cell mass is the one which will form the embryo or the fetus or the baby, whatever you want to call it, right? So I am telling you that this blastocyst has got two layers and the inner cell mass will form the embryo or the baby. So my question here is, what will the trophoblast do? Why at all is my body forming the trophoblast? So the answer is that this trophoblast will form the placenta and the membranes of the baby. Now, I think you all are very familiar that a baby is surrounded by some membranes. What are these membranes? Amnion and chorion, right? The membranes are amnion and chorion. So yes, the baby is surrounded by membranes, and when we say that the membranes have ruptured during labor, by membranes I actually mean that the amnion and the chorion has ruptured in a pregnant mother. Okay, so yes, now let us look at this inner cell mass first, and then we'll see what the function of the trophoblast is in details. So yes, now what I'm drawing is I told you that the outer layer is the trophoblast, which is further divided into the syncytiotrophoblast and the cytotrophoblast. So I can take this as the syncytio and this is the cyto. What am I drawing? I am drawing a zygote. I am drawing a zygote or a blastocyst, and I am trying to show you the further development. And I told you that the inner portion was the inner cell mass, right? This was the inner cell mass. So this inner cell mass will undergo further development. This inner cell mass will now differentiate into two layers. What are those two layers? This layer is known as the epiblast, and epiblast, these are actually columnar cells. They are tall columnar cells as you can see them, and they will in future develop into the ectoderm. And there is one more layer of cells. There is one more layer of cells, which is this layer. What am I drawing right now is the hypoblast. Hypoblasts are actually, as you can see in the diagram, they are flattened cells and they will in future develop into the endoderm. So why am I calling this layer as epiblast? Because epi means above. This layer is above and hypo means below. This layer is below, right? So my inner cell mass, which will actually form the baby, has differentiated into the epiblast and hypoblast. Now, a small piece of information that I want you to know is that all the tissues in our body are formed of three germ layers, right? Everything in our body is made up of these three germ layers, which is ectoderm, mesoderm, and the endoderm. So, these are the three germ layers. Now, in this diagram, I have told you about the ectoderm. I have told you about the endoderm. My question is, where is the mesoderm? Ideally, to form all the tissues in my body, I should also have the mesoderm, but I do not have it right now. So yes, this diagram is not wrong. This is correct. In the primitive stage, I have only two layers, right? the ectoderm and the endoderm. Mesoderm is not there right now. So what will I call this germ disc? I will call this germ disc a bilaminar germ disc. And what do I mean by bi? Bi means two, which means there are only two layers formed right now. Okay. Now, I want you to understand that this epiblast will grow all around 360 degree inside the cytotrophoblast. Similarly, this hypoblast will grow all around 360 degree, right? So what am I trying to say is, if I further try to develop the diagram, this is my syncytial trophoblast, this is my cytotrophoblast, and I had formed the epiblast in the hypoblast. So yes, this was the epiblast and this was the hypoblast. So can you see that with the formation of the epiblast and the hypoblast, I have divided the zygote into two cavities. Since these layers have grown all inside the cytotrophoblast, I have divided the zygote into two cavities. What will I name those cavities? This is the amniotic cavity and this is the yolk sac. Now this is the primary yolk sac, okay? At this portion I will call it a primary yolk sac and I have a bilaminar germ disc as I told you earlier. Now after this, what happens is, this trophoblast layer will give in another layer of cells. This will give in another layer of cells, right? So what is that layer of cells that it gives in? I am drawing it in blue. The cytotrophoblast has given in another layer of cells, okay? So what is this known as? This is nothing but, this is known as this blue layer that I have drawn, this is known as the mesoderm. But mind you, this mesoderm is extra embryonic. Why am I calling it extra embryonic? Is because this portion is going to form my embryo and this mesoderm is lying outside the embryo. This is lying outside the embryo, which means this will not participate in the tissue formation. This will not participate in the formation of the embryo proper, right? So this is my extra embryonic mesoderm. Now, I am taking it one step further, okay? So now I am telling you that this extra embryonic mesoderm will develop a few cavities, right? This will develop a few cavities and these cavities will unite together. These cavities will unite together, right? So if I draw it again, for you, I had the mesoderm all around, right? And I said that there would be formation of cavities. So after the formation of the cavities, my image somewhat looks like this, right? My image somewhat looks like this. I have formed a cavity. If I try to outline the cavity, this is the cavity. And we know that cavity is nothing but a coelom. And where is the coelom formed? It is formed in the extraembryonic mesoderm. So we will call it extraembryonic coelom. Right? This is the extraembryonic coelom. Now, one peculiar point that I want you to understand over here is that this extraembryonic coelom is not extending to the region of the amniotic sac. Can you see that this coelom, I have deliberately drawn it only in the region of the yolk sac. So, another point I want you to understand that as soon as the coelom forms, my yolk sac will now be known as the secondary yolk sac. When there was no coelom formation, like in the previous diagram, it was a primary yolk sac, and now it is a secondary yolk sac. So, with the formation of this cavity, I now want you to understand that I have formed two very important structures in the baby. What are they? They are the amnion and the chorion. Yes, they are these membranes that I have already formed in the diagram, and I'll show you in a moment. See, this layer that I have formed, this is the outer layer. This is known as the chorion. And this layer that I have formed, this is the inner layer, and this is known as the amnion. Also, I would want you to understand that with the formation of the coelom, I have divided the extraembryonic mesoderm further into two layers. Can you see that this is one layer of extraembryonic mesoderm and this is one layer of extraembryonic mesoderm that I have formed? So this inner layer of extraembryonic mesoderm is known as splanchnopluric extraembryonic mesoderm, and this outer layer is known as somatopluric extraembryonic mesoderm. So now if I ask you that what is the chorion made up of, the chorion is made up of somatopluric extraembryonic mesoderm with the cytotrophoblast, the inner layer of the trophoblast. So yes, somatopluric combined with the cytotrophoblast has formed my chorion, right? And amnion has been formed by the splanchnopluric extraembryonic mesoderm because the cavity did not invade it further, and the epiblast. The purple lining that I have drawn is the epiblast, right? So yes, I have formed those two membranes, the chorion and the amnion in the baby, right? These are the placental membranes that I have already formed. Now, also one thing I want you to understand is this area where the coelom does not invade, right? In the region of the amniotic cavity where the coelom does not invade is very important to me because this region will form the connecting stalk in the baby, right? This is known as the connecting stalk. So now at this moment, and remember that connecting stalk will form the future umbilical cord, right? So now at this moment, I want you to take you to the another diagram, which is, yes. So I want you to understand this diagram, which will make it a bit clear. So yes, like I told you, this was the outer layer of the trophoblast, and this was lined by endoderm, and this was the amniotic area, which was lined by the ectoderm. So now I move further, and if I take a look at this diagram, I had told you this is my primary yolk sac, this is the amniotic cavity, the yellow colored area. The primary yolk sac is lined by endoderm, the amniotic cavity is lined by ectoderm. Let's move further. Then I told you that the trophoblast gives in another layer, which is the extraembryonic mesoderm, right? This purple area is the extraembryonic mesoderm, and then cavities developed in the region of the extraembryonic mesoderm. They fused together and they formed an extraembryonic coelom, as you can see in the diagram, right? But did you see that this extraembryonic coelom did not invade in the region of the amniotic cavity? And can you see the amnion and the chorion like I explained in the diagram? So yes, now I want you to understand our diagram further. Let's take it further. I told you that this was the epiblast and this was the hypoblast in the previous diagram, and this was forming my ectoderm and this was forming my endoderm. Now I asked you one question, that where is the mesoderm in the baby? So yes, now we'll form the mesoderm. This ectoderm will elevate and form a procaudal plate. On one side it gets elevated and forms a procaudal plate, and this procaudal plate gives in some cells which are mesoderm. So mesoderm will come to lie in between the ectoderm and the endoderm, and this mesoderm, mind you, is intraembryonic, because this will take part in the formation of the fetal tissues, unlike the extraembryonic mesoderm which was not participating. Yes, so this is the intraembryonic mesoderm. Also, I want you to understand that as the baby grows, baby keeps on folding upon itself. So yes, take a look at this diagram. Can you see that now mesoderm have formed in this diagram in between the ectoderm and the endoderm? This is the extraembryonic coelom, and the entire diagram remains the same. Now I want you to understand that the connecting stalk which I had drawn in this area, as the baby grows, the connecting stalk keeps on moving to the ventral side of the baby. We will discuss this again. Let's move on. Again, yes. So if you look at this diagram once again, this is my amniotic cavity, this is my yolk sac. Then the coelom, mesoderm had invaded, then a coelom had formed, then there was a region of the connecting stalk. Now, there is another thing, that this amniotic cavity will keep on folding, right? This will keep on folding, and what will go inside it is the yolk sac. So this keeps on folding with the yolk sac coming inside it, right? And this will form two poles in my embryo, right? The caudal and the cranial ends are formed. Also, at this stage, the yolk sac is known as the definitive yolk sac. So I have told you primary yolk sac, secondary yolk sac, and now at this stage when it becomes very small, this is known as the definitive yolk sac. So the amniotic cavity keeps on folding and it is connected in the region of the connecting stalk. So can you see the amniotic cavity has folded, the yolk sac is very small, it has gone inside the amniotic cavity. And how is it connected? It is connected by the connecting stalk. This connecting stalk has come to the ventral surface of the baby. This has come to the ventral surface. What do I mean by the ventral surface? I mean the region of the umbilicus of the baby. Why has it come? Because now it will form the umbilical cord in the baby. And this umbilical cord has to attach to the mother or the uterus of the mother, right? It has to attach to the uterus, but how will it attach? It will attach via a structure which we are going to read further, which is the placenta, right? We are going to read about the placenta. But now, can you tell me that umbilical cord is a derivative of what? Umbilical cord, if I ask you, it is a derivative of the connecting stalk, yes, and the connecting stalk is a derivative of what? It is a derivative of that retained extraembryonic mesoderm. Can you recall? Yes. So if someone asks you what is it a derivative of, it is a derivative of extraembryonic mesoderm. Now let's move further. Let's take it one step ahead. Yes. So we have completed the embryo formation. Okay. Now let's see what will happen with the cytotrophoblast and the syncytiotrophoblastic layer. Okay. But before that, I want you to know a bit about the uterus of the mother. See, this is the uterus that I'm drawing. The uterus has got, as you all must be knowing, 3 layers. That is the perimetrium, the myometrium, and the endometrium. Okay, so from outside in, these are the 3 layers, and what I am doing is I am dividing my endometrium further into 3 layers. What are they? Zona compacta, zona spongiosa, and zona basalis. Now, this basalis is actually facing the myometrium, and the compacta is the one which is facing the uterine cavity, right? This is facing the inner side. So, now I want you to understand that the fetus is going to attach to the uterus. It is going to attach to the uterus through the placenta, which I told you in the previous diagram, right? It will attach to the placenta. For the time being, let's keep this placenta aside, right? Let's look at the mother's uterus. So, I want you to understand roughly that if I take this to be the cavity, this is the baby that we have already formed. The baby has an umbilical cord. The baby has an umbilical cord. This umbilical cord is attached to the placenta, and the placenta in turn is attached to the uterus. This is the diagram that I roughly want you to understand. So, now let's look at the placenta. This placenta will attach only to the endometrium of the mother, right? It will attach only to the endometrium of the mother. It will not go beyond it. It will not go beyond it. Because if it goes into the myometrium, it will not be able to shed off. As you must be knowing that the 3rd stage of labor comprises of the expulsion of the placenta and the membranes. It is after the delivery of the baby that the placenta and the membranes have to deliver out, right? So if it invades deeper into the myometrium, that is the muscle layer, will it be able to deliver out? No, never. That is why, remember that this will be limited only to the layer of the endometrium, right? Let's now look at the placenta. As you would recall, I had told you that this is my syncytiotrophoblastic, this is my cytotrophoblast, and I had formed another layer which was the extraembryonic mesoderm, right? I had formed it, and I did not tell you the function back then. Now I am going to tell you. What I am doing is, I am showing you, okay, you need to understand that this syncytiotrophoblastic gives many finger-like projections, okay? All around it gives finger-like projections. So what I'll do is, I'll take up this section and enlarge it. So this is what? This is my syncytiotrophoblastic. What is inside it? What is inside it is the cytotrophoblast, right? The syncytiotrophoblastic, and then the cytotrophoblast also goes inside it, right? The inner layer also goes inside it. So what am I calling it now? This is my primary villi, right? This structure is known as the primary villi. Now what I'll do is, I'll make this extraembryonic mesoderm, the one which I've drawn in blue, and make this also go inside, right? This is the extraembryonic mesoderm which has gone inside. Now when the extraembryonic mesoderm goes inside this primary villus structure, I will call it as secondary villi. And why did I make this mesoderm grow inside the villi? Because only when the mesoderm grows inside, then only will blood vessels come, right? Blood vessels will come only when the mesoderm forms. So when the blood vessels have formed, I will call it a tertiary villi, right? I will call it a tertiary villi. Now, I will take this one step further. So this is one villi that I have shown you. What I'll do is, I'll make more such villi. This is present all around the baby, right? I have formed so many villi. There are actually many villi, okay? So this is the villi. Yes. This is the cytoplasm. Yes. The intraembryonic mesoderm. This is the intraembryonic mesoderm. And then this is the blood vessel which is running inside. Now I want you to understand another thing, that this layer of the cytoplasm which I have formed will grow above. Similarly here it will go up and it will perforate my syncytial trophoblast. Okay, this will perforate my syncytial trophoblast, so I can technically draw it to be like this. This cytotrophoblast goes above the level of the syncytial trophoblast, it perforates and it connects all around. This one will connect with this, right? And this will form a shell all around. What will I call it, this shell? I will call it as a cytotrophoblastic shell. Okay, this is a cytotrophoblastic shell. Now what will happen is, from the maternal side, blood vessels will come in, piercing this shell. These are maternal blood vessels. What are these? These are maternal blood vessels, and these are fetal blood vessels. These maternal blood vessels are present where? They are present in between two villi. So can I tell that these maternal blood vessels are actually present in the intervillous space? Intervillous means in between the two villi, and the fetal blood vessel is present inside the villi, right? It is present inside the villi. So what I am trying to show you over here is that maternal blood and fetal blood are not combining. No, they are not combining because of this barrier that I have formed. This is known as the placental barrier, right? So they will not combine. But what they will do is, they will exchange a lot of things. They will exchange oxygen, carbon dioxide, nutrients. So they are exchanging a lot of things, and that is what is the function of the placenta. What I have formed over here, this entire thing is nothing but the placenta, right? I have formed the placenta. This placenta is what? This placenta is this thing which will attach to the uterine cavity of the mother. Now let's do one thing. Let us attach it to the uterine cavity. So let us draw the uterus once again. Let us draw only the cavity of the uterus. I told you that the zygote comes in and it will attach to the endometrium of the mother and not go beyond it, right? So this goes inside, the zygote goes inside, and then it gives away those villi, right? It gives away those villi all around. This is the zygote with those villi. And let me tell you that when the zygote is trying to go beyond the endometrium into the myometrium, what happens is there are fibrinoid deposits. Fibrinoid deposits in the basalis layer, which I told you earlier, right? The innermost layer of the endometrium. The basalis layer, there are fibrinoid deposits which will prevent the further invasion of the placenta into the myometrium. So what is this layer known as? This is known as the metabux layer, right? Just remember it. This is known as the metabux layer. Okay. Also, now as the zygote implants the endometrium, the epithelium grows around it because it wants a firm grip over the zygote. Okay. So it grows all around the zygote. So now can you see that again the endometrium can be divided into a lot of areas, right? Now once fertilization has occurred and implantation has occurred, my endometrium can be called as a decidua, right? So decidua is nothing but a pregnant uterus. Decidua literally means to shed off. So after pregnancy this will shed off, okay? So I call it decidua. And now in the pregnant uterus I have divided my endometrium further into 3 layers. This is very easy to understand. The area where the zygote is implanting, this area is known as the decidua. This is known as the decidua basalis, okay? This is known as the decidua basalis. The region of the endometrium which is surrounding the rest of the portion of the baby, this region is known as the decidua capsularis. You can also understand it like it is forming a capsule around the baby, so it is forming a decidua capsularis. And this remaining portion will be called a decidua parietalis or the vera, which is not in contact with the embryo, right? So this is something you need to understand, that I have further divided my endometrium into basalis, into the capsularis and into the decidua vera, right? And also at this stage, can you see that this is my uterine cavity which is still intact, and this is the baby, okay? Now let us try to develop this concept further. Right. So I told you that the amniotic cavity keeps on folding upon itself. Can you recall? It keeps on folding upon itself and the yolk sac goes within it. So you can see it very well in the diagram that the amniotic cavity with the baby has folded, and this is the yolk sac. This is the definitive yolk sac which has become very small and it has gone inside the amniotic cavity. And this whitish area is the extraembryonic coelom, right? And this purplish area is the uterine cavity, and this is the amniotic cavity which I told you. So at this stage you can see 3 cavities: the amniotic cavity, the extraembryonic coelom and the uterine cavity. Now what happens is, and also if you would understand that we had drawn this layer as the chorion and this as the amnion in our previous diagram. So what happens is, as the baby grows, it will grow at the expense of the extraembryonic coelom. By this I mean that this will obliterate the extraembryonic coelom, right? So now in this diagram, you see, if I make this amnion, the amniotic cavity grow bigger, can you imagine that my chorion and amnion will fuse together, because what I have done is I have obliterated the coelom. So amnion and chorion will fuse together. So yes, I have obliterated the coelom. What I have remaining is the uterine cavity. Can you see this umbilical cord has formed? And this umbilical cord is connected to the placenta. The placenta in turn is attached to the uterus. In the uterus, it is attached to the portion of the decidua basalis, right? Just a second, we'll go back to the previous diagram. See, decidua basalis is the region which is in contact with the baby or the placenta, right? The decidua capsularis is this surrounding region. This is in contact with the remaining part and not with the placenta. So what do I call it? This is decidua capsularis. And the rest of the uterine tissue, the endometrium, is the decidua parietalis. So yes, let's go further. So I have obliterated the extremyonic coelom, and what I have remaining is the uterine cavity. Now, as the baby grows further, it will obliterate the uterine cavity also. So yes, now I can form a I can see a fully developed fetus or the baby, right? Yes. So let's move on. Also, this decidua basalis, right? This decidua basalis with the placenta, the fetal side of the placenta, is what is known as the chorionic frondosome. This portion has those villi which I told you, and the villi in the remaining part will get obliterated. They will get obliterated. They are of no use to me, right? This portion is known as a chorion leaf, okay? This remaining portion. This is forming the membranes, as you can see. The chorion and the amnion, yes. And the chorionic frondosome is the actual area of the fetus which is forming the placenta. So these are just two terminologies you can keep in mind. Now let's move on further. Let's see what we have read about. See, I told you that there are tertiary villi. Can you see these are tertiary villi? And I told you tertiary villi will have blood vessels from the fetal side, right? So I have this umbilical cord. From the umbilical cord, I have the umbilical vein, the umbilical artery coming in and going out, right? They will divide, form capillaries and get this fetal blood into the tertiary villi, right? Now I want you to focus onto this whitish area. This whitish area or the inner lining is the cytotrophoblast. This cytotrophoblast you can see has basically ruptured sensation trophoblast and grown all around. So what has it formed? It has formed a shell, right? It has formed a shell, cytotrophoblastic shell all around. And this greenish area is the sensation trophoblast. The sensation trophoblast, like I told you earlier, will have the maternal blood pouring in, right? So this is all that you need to understand about the placenta. Also, the portion that I told you was the fetal side of the placenta. Fetal side of the placenta was contributing 4/5 to the placenta formation, and this portion is the maternal side of the placenta, right? This portion is the maternal side of the placenta, which is contributing only 1/5 to the placenta formation, right? So let's see what we have read. What I told you till now is, if this is my uterine cavity, I have formed the baby. I have attached the baby with the ventral surface by means of the umbilical cord to the placenta, right? And what was the placenta doing? It was attaching onto the uterine cavity, right? Also, you can take down one more point is that the implantation occurs in the region of the posterior part of the fundus of the uterus most commonly, right? This is the area of implantation. So yes, this is what we have learned about. Now, this is the end, right? Now guys, this was my first video. I would definitely like to know how you liked this video. Please drop a comment saying how you liked it and if there are any improvements that I need to make. And if you found any error in the video, do let me know, because even I am at the learning stage right now. Yes. So, the end. Please like, share, and subscribe. Yes, you know the drill. I need not tell you again. So, yes. I hope I made it easy for you. Bye bye. Thank you so much for watching.